Okay, viewers, let's consider this question. Okay, one of the subscribers tested me with this question. Okay, so let's see how we can do justice to the question. So solve. So solve, all right. So probably, or perhaps, we are solving for, or we want to know what the complex number z is equal to. Or you look for the real part of the complex number and the imaginary part of the complex number. Okay. So we are solving for this. Viewers, we know that e to the power pi over 3I all squared is the same as e to the power. Our basic algebra will tell us that 2 multiplies this, right? So we have 2 pi over 3I. Is that also? That's what it means, right? Good. So we already know that complex number z is equal to what? R, then exponential I theta, right? I theta over here. Is that also? Good. Viewers, if this is your first time watching this channel, visit my previous lecture videos. We've dealt with stuff like this, okay, into details. So by comparison, we can say that then this I is equal to this I, right? Then I can say then my theta here is equal to my 2 pi over 3. That's what it means. And R here, so which means there's 1 over here. So which means R is equal to 1. That's what it means by comparison. So by comparison, R goes to 1. This is E, right? I, theta also is equal to theta. And we know that in polar form, so complex number in polar form is, that's cos what? Cos theta plus I sine what? Theta. We've been doing this all this while, right? Good. So here, what do we have? We have R to be equal to what? 1. Is that also 1? So what do we have? Cos. Cos of the angle theta. What is cos of the angle theta? Theta is what? 2 pi over 3. Then plus I, then sine what? 2 pi over 3 this way. It's more like 1 over here. You see, multiplying everything. As simple as that. So viewers, so this complex number z is equal to, so when you evaluate this, okay, this should give us the x part. Complex number, this is the real part. So it's like this side is the real part, and this part is the imaginary part. Okay, so you have your I over here. So when you evaluate this using the calculator, you should get that's negative 1 over 2. Then here, when you evaluate this using the calculator, you should get that's root 3 over 2 over here. Is that also? Then you have your I over here. What are you doing? X is adding to Y. So you add plus add. If you don't get it this way, you can do it this way. You can say let's, okay, this side, let x be equal to what? Cos what? 2 pi over 3. Then the whole of this should be equal to y. So let y be equal to what? I sine what? 2 pi over 3. This is the whole concept, okay? So your complex number z is equal to, you add x to y, so I have x plus I over y. As simple as that. So therefore, I see that the z is given by what? X, okay? So when you evaluate this, what is x? X is equal to, so when you evaluate this, you should get negative half for the x. Now, when you evaluate y, you should get root 3 over 2. So therefore, your final answer becomes negative half, then plus root 3, then all over 2 what? I. As simple as that. And this is just the same as negative half plus I root 3, then over 2. This is the end of the question. And the second one, to end everything, it's just the same concept, okay? So we have fourth root of 10 multiplying exponential pi over 2i. This simply means to the power 1 over 4, right? So viewers, this is the same as I have e exponential pi over 2i, okay? And this is the same as to the power what? 1 over 4. Do you get it that way? So what happens? This affects that and affects that. So you have a x to the power n. So we have a n, they have x n. This affects this and also what affects that. So this will affect this and also affect that. So this is the same as 10 to the power 1 over 4. Then exponential what? Pi over 2i times what? 1 over 4. Remember, this is to the power 1, okay? So it's like 1 times the power for this. Then this times the power. So this is just 10 to the power 1 over 4. Then times exponential. You have pi I divided by what? 42 divided by 8. Okay, so using the same concept or ideology, you can say that complex number represented in the polar form is r, then cos theta plus what? I sine theta. Is that not so? So what is r? So r here is, this is my r by comparison. So what is my r, okay? So by comparison, you already know that. By comparison, you already know that you have something like r e to the power I what? Theta. So by comparison, this r is equal to 10 to the power 1 over 4, right? So r is equal to 10 to the power 1 over 4. Then what is theta? This, so you see I is equal to I. So therefore, pi over 8 is equal to the theta. This is the same as pi over 8. So this is the exponential way of representing complex numbers. You have z is equal to r cos theta plus I sine what? Sine theta. This is the polar way of, or the circular way of representing complex numbers. So therefore, we have z to be equal to r. What is my r? R here is what? Is 10 to the power 1 over 4. Okay. Then multiplying cos of the angle theta. Theta here is what? Pi over 8. Then plus I, then sine. What do you have? Pi over 8. This way. This way. As simple as that. So you can say, let, this is x and this is what? Y. Is that not so? So we have, let x to be equal to cos pi over 8. Do you get it that way? And y equals this. Or you can simply do this. You can simply say, so viewers, okay, so this is the same as, you can say let x represent this and let y represent this. Remember, this is multiplying the x component and this is also multiplying the y component, right? You can just do it straight away. This is a calculator work. So you have z is equal to, you have 10 to the power 1 over 4. Multiplying the whole of this, that's the x component, right? X and y times cos pi over 8. Then what do we have? Plus in the middle, plus. Then we have this 10 to the power 1 over 4, multiplying the y, which is I sine, then I have pi over my 8. As simple as that. Viewers, using calculator to compute this, z should give us 1.64 then plus 0.68i. As simple as that. So this is just the same as 1.64 plus I 0.68. As simple as that. Viewers, this is the end of the tutorials under complex numbers. I really appreciate your time, your effort, and your hard working. Questions will still be appreciated in any ways, right? Bye.